Welcome back to the channel, and in this video I'm going to go through the operation of a rotor earth fault monitoring board for a turbo generator. You can see the two boards there are the receiver boards. I've got a couple of boards to play with. One of the boards needs refurbishment, and one of them actually has a fault on it and won't detect a fault at all. So I'll reconfigure and then we can go through the system and the setup and how one of the boards operates. So on a turbo generator that I work on, the rotor itself is basically a big spinning electromagnet that has a DC supply going into it, come from what we call an automatic voltage regulator, often shortened to AVR, and the supply that provides is DC supply, but it's unearthed. So in that respect, a rotor winding can suffer one single earth fault and it will still operate without issue. However, a second earth fault has the potential to short out a section of the winding and create an awful lot of mechanical and electrical damage to the machine itself. So what the manufacturers do is provide a monitoring facility that gives either an alarm out to the control system to say you have an earth fault, or does in fact trip the generator itself. Now, if you have what's called a static excitation system, I'll put a picture up of that. That is a rotor with a set of slip rings and brushes. So there is a direct electrical circuit between the AVR and the generator rotor, and to monitor that system for earth faults is a relatively easy function to do. If you have a brushless excitation system, the connection between the rotor winding and the AVR is in actual fact magnetically induced. Therefore you have to have a different system in order to monitor it and detect potential earth faults. So some manufacturers, as you see in this picture here, put a set of instrumentation slip rings on the end of the rotor, and they use that, and that actually provides the direct electrical contact to the AVR and allows the earth fault monitoring to be performed. Other manufacturers provide a wireless monitoring system, and that's the board that you see sat in front of the two instruments here. So the board you see is the receiver board. There is a transmitter that is installed on the end of the rotor that actually spins 3000 RPM with the rotor. I'll show you a picture of that as well. Once you have excitation on the system, that transmitter is putting a signal out that this receiver board picks up. If you have an earth fault on the rotor, that suppresses the signal from the transmitter, and then this board doesn't pick up any signal and it instead puts out an earth fault alarm. Now, to carry out a bench test of the system, you can set up a transmitter along with an aerial connected into the receiver board, or you can do as I'm doing here and generate a signal from a function generator. You can see the signal from the manufacturer here on the screen, and pretty much any signal generator with a burst mode is capable of generating this signal. And I'll put up two screen captures from the oscilloscope, and you can see how they match the specifications from the manufacturer. So at the moment we're set up with the signal on the oscilloscope, and it's not on the actual rotor earth fault receiver board. So the board is in fault mode, and you can see that with the 6 ohm reading on the multimeter there showing that the contact is actually closed, and on the left there you can see all 4 lights are lit up. So the top light is a board supply inhibit that will prevent the alarm going into the system if there's no supply to the board. The second one is an excitation inhibit, which again will prevent a rotor earth fault signal going into the system if the excitation isn't present. The third LED down here is the actual earth fault protection detected, and the fourth one here is just to supply healthy light. So I'll transfer the signal over to the board. Okay, so I've just reconfigured and zoomed the camera into the actual board itself. I've moved the signal over to the board, but I've not switched on the function generator. As a consequence, the fault LED is lit and the contact is showing short circuit. If I switch on the signal from the function generator, you'll see the earth fault detection LED will go out and the meter should show an open circuit. There you go, so we know that's operating okay. So what I will do is get a little shorting wire, and I will test the remote switch, which is on terminals 3 and 4, this is where the remote switch would normally be wired through in the system. Effectively it just removes the signal by opening this little relay here, and makes the receiver think that there's an actual earth fault. So we'll do that as well. There you see, earth fault's come on, the relay is closed again and opens again straight away when I take it away. So that's the basic operation of the little board. Okay, so that's how I go about testing a rotor earth fault receiver board from a brushless generator. I had 2 boards to test there. The board on the right there that I've tested successfully. There's a bit of a refurbishment work, some capacitors were replaced on that. This board here on the left, unfortunately, the secondary winding that feeds the excitation detection circuit is open circuit. That's quite a bespoke transformer wind. It's encapsulated, so it'll be hard to get that rewound. You might be able to get a replacement transformer from the manufacturer of the board, or it might be that you can do a service exchange on it. But at the moment, that board there on the left, I can't actually fix myself, which is a bit of a shame. But we did get the board on the right going okay, so we have at least 1 spare board available. So that's it for this video. I hope you found it useful. Thanks for watching, and I'll see you again in the next one.